Let's look at the integral test. The integral test says if f is positive, continuous, and decreasing for all x greater than 1, and if I can write a sub n is equal to s sub n, then the sum as n goes from 1 to infinity of a sub n and the integral from 1 to infinity of f of x dx either both converge or diverge. So you need to show three things: positive, continuous, and decreasing. So let's try and use the integral test. Is this positive? Let me rewrite this. A sub n is n over n squared plus 1. So f of x is x over x squared plus 1. Now, is f of x positive for x greater than 1? And indeed it is. Is f of x continuous? Yes. Yep. Yes, it is. It's a ratio of two polynomials, and the denominator never goes to 0. Now, is it decreasing? Well, let's look at the first derivative of f of x, and let's see if that's negative. If I take the first derivative, this is going to be x squared plus 1 times 1 minus x times 2x, I'm using the quotient rule here, x squared plus 1 quantity squared. Now I'm going to rewrite this as minus x squared plus 1 divided by x squared plus 1 quantity squared. And this is indeed negative for all x greater than 1. So f of x is decreasing. So I've shown the three criterion. So now all I need to do is find the integral of f of x dx from 1 to infinity. And if that converges, then my sum converges. If it diverges, then my sum diverges. So I'm going to look at the integral, pen's not working, from 1 to infinity of x divided by x squared plus 1 dx. Now this is, let me get this in terms here. I'm just going to do a little trick here. 2x dx divided by x squared plus 1. So now I have du over u. Now this is an improper integral, and by the way, you're always going to have to do this. So this is a limit as b approaches infinity of the integral from 1 to b of 2x dx divided by x squared plus 1. I could do the whole u to u substitution, but I won't. In this case, this is 1/2 times the limit as b approaches infinity of the natural log of x squared plus 1 evaluated at 1 and b. So this is 1/2 times the limit as b approaches infinity of the natural log of b squared plus 1 minus the natural log of 2. Now we see this is infinity. So that tells me the sum as n goes from 1 to infinity of n over n squared plus 1 diverges. Now, what if we use the integral test on the sum as n goes from 1 to infinity of 1 over n squared? Well, again, you have to write f of x is 1 over x squared plus 1. This is continuous for x greater than 1. The next thing you need to check is it decreasing? F prime of x is equal to, let's see, minus 1 over x squared plus 1 squared times 2x. And this is indeed negative for x greater than 1, so it is decreasing. The last thing we need to check is f of x positive. All right. And this is positive for all x, so it is positive. So that tells me that the integral from 1 to infinity of 1 over x squared plus 1 dx equals the limit as b approaches infinity of the integral from 1 to b of dx divided by x squared plus 1. So this is a limit as b approaches infinity. Let me do this integral. This is an inverse tangent, of course. So this is the inverse tangent of x evaluated at 1 and b. Extend my page here. So this is the limit as b approaches infinity of the inverse tangent of b minus the inverse tangent of 1, which is just, let's see, this is going to be, what is this limit? Let me put my parentheses in here. Inverse tangent of 1 is pi over 4, so this is pi over 2 minus pi over 4, or pi over 4. So the theorem tells me that the series, as in goes from 1 to infinity, of 1 over n squared plus 1 converges.